Hey guys, welcome to the level 2 probability paper from 2022. If you're joining us for the first time, the way this video works is that I go through each question, let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about with the answer. Now this is the first time I'm doing this probability level 2. So most likely I'll probably mess up somewhere, so if I do, please feel free to add comments, and of course if you find easier ways of doing things as well, just let me know in the comments, as it is a learning experience. So without further ado, let's get started. Okay, so question 1, what we've got here is a normal distribution question. We've got the mean happens to be 227 and the standard deviation is 16, and we're asked to figure out the probability for between 227 and 247. So what we're going to do is we're going to use the calculator for this. So if you go into your graphics calculator, go into stat mode, and under stat mode you've got distributions, click on normal distribution, and then the one we're using is NCEA. So our lower limit is 227, our upper limit is 247, standard deviation is 16, and the mean is 227. So we punch that in and we've got an answer of 0.3944. So what we're going to do is we're going to write this as probability 247 is equal to 0.3944. Now, as I said to you folks, this is the first time I'm doing this paper, so I'm looking at the answer schedule, and I'll show you guys the answer schedule as well. So as you guys can see, 0.3944. I'm not sure if you need this step or not, but considering it's an achieved question, I would probably say you can probably go directly to the answer itself. So this is what an achieved grade, and then we move on to the next question. Okay, so with the next question, we're still working with the same mean and standard deviation. So our mean is going to be 227 and our standard deviation is going to be 16. And the question is asking what is the probability that they both use less than 210 liters per day. So the first thing we've got to figure out is what's the probability of it being less than 210. So for this part here, I'm not sure if things have changed or not, but because like I said to you guys, I've not done this in a while, but the way I've been kind of doing this is I'd still go back to CD, but what I did do is, like, because I want to find it between less than 210, I almost put down like try and put negative infinity, but you can't, so I put the lower limit as like almost something ridiculous like this, and then upper I put it as 210. The standard deviation and the mean is still the same, and when I do this, the probability is equal to 0.144. Now the reason why I put that number is because if you think about it like this, right, so here's where the bell curve is. 227 is here and 210 is probably somewhere there, and we are looking for less than 210. And because I guess the reason I use negative 999 is, well, how many ever is that it kind of goes all the way to the end there, unless things have changed. The last time I did this was almost like 8 years ago, so unless things have changed since then, I do apologize if this is a long way, but if you do have a shortcut method, please pop it in the comments below. Now the question also is asking for, like, what's the probability they both use less than 210. So for probability of both, we actually want to multiply 0.144 by 0.144. So when we do that, we're going to be looking at menu. Let's go this 0.144 times 0.144. That's going to give me 0.0207. Now the grades wise, probability of 0.144 is going to get you an achieved. Looks like this is one of those weird questions where there's like second part of it. So for a merit, you have to actually get the second part of this question correct. So let's answer that one first. Let me show you. So as you guys can see, like the 0.144 will get you an achieved, but to get the merit for that, you've got to answer the second part of this question as well. So I'm going to go back to the second part of the question to have a look at that. So if we look at this second part of the question, it says, you know, what would happen if they were chosen from areas that experience water shortage? Now, if you think about it, you know, if they experience water shortage, then the probability that they use less than 210, like it'll actually be higher. Like there'll be a, compared to New Zealand, right? So you'd actually expect this answer to be higher, and that's pretty much what I'm gonna write down. So as I was saying before, if people have like water shortage, they might use less water, so the probability that they will use less than 210 will be much higher compared to New Zealand. So this answer would actually be much higher. So writing this and then getting that probability of 0.207 is going to get you a merit. So you need the probability and you need this particular statement as well. All right, let's go to the next question. Alright guys, so for this question here, what I'm going to do is, I mean, there is quite a bit that we can actually talk about. The first thing that we're going to try and work out is, I mean, we've been given the mean of 8 and standard deviation of 2, and we've been asked to discuss at least 2 of center shape or spread in the answer, right? So the first thing I'm going to do is I'm going to work out what the median is. Looking at the actual frequency here, I've got 1, I've got 4, 7, 13, 8, what is this? 5, 3, 4, 1, 4. When I add that up, I actually get 50, and I know the median is going to be at 25, between 25 and 26. So if I'll go along here, 25 and 26, that's literally 25 and 26 is at the 8-minute mark. So I can kind of say that the median is going to be, median is approximately 8. So the first thing we can talk about is the center here. Center, the first thing we can say is median is approximately the same as mean. I would put the units, the numbers as well. So the same as mean, so that's 8, and then that's 8 as well, the median. You could also work out the actual mean of this. So what I mean by that is I've got 1 times 1 plus 4 times 3, which is the middle of 2 and 4, plus 7 times 5 plus 13 times 7 plus 8 times 9 plus 5 times 11 plus 3 times 13 plus 4 times 15 plus 1 times 17 plus 4 times 19. So basically all I've done there is I've multiplied the frequency with the midpoint of those values, which gives me 458, and then I know that I've got 50, the frequency is 50. So when I do that, I actually get 9.16. So the other way you could kind of counter argue that is the mean, the actual mean, which is 9.16, is higher than the given mean, which was 8. So you can say something like, so the means are not equal. The next bullet point that we can kind of talk about is how, like in normal distribution, your mean slash median mode will all be the same, but in this case they're not the same. So that's another point you can talk about, how mean, median, and mode, mode being the most common ones, and I think, you know, that 6 to 8 is kind of like messing it up a little bit. So in this data is not all the same. Sorry, I'm just going to write them as bullet points. The shape, you could talk about the shape. Now the shape is, it's a normal shape is normally bell shaped, but in this one you can kind of see that it's skewed to the right. So if I look at it there's a little bit of a skew happening to the right. So you could talk about skew to the right. I'm just going to write this as bullet points, guys, but in your exam, please make sure you write it in statements. The spread, you can talk about the spread. So the normal distribution standard deviation is 2. So if it's 2, then normally we can go plus or minus 3 standard deviations. So if you go 8 plus or minus 3 times the standard deviation, you are going to get between 2 and 14. So that's what it suggests that the spread should be. But then Suzanne's data has actually got a lot more, because hers is it's got a range of 20. So you can actually, but her data is from 0 to 20. Okay, so it's actually got a much larger standard deviation than compared to the normal distribution one. So in terms of grades wise, you need one statement for merit, one statement for achieved, and you need 2 statements for merit. All right, let's go to the next question. So the next part of this question is, we're still working with the same mean and standard deviation. So we still got a mean of 8, standard deviation of 2, but she considers only 15% of the shower times to be acceptable. So what we've got here is the left tail. So this part here is going to be 0.15. We want to know what this value is. We know that mean is 8 and standard deviation is 2. So we're going to go straight into the graphics calculator and go into stats mode. And under there, we're going to go to distribution, normal, inverse. I've already done, no, I was messing around with this. So what is our area? So area is equal to 0.15. So that's the left tail. And we do need to mention that it's the left tail at the top there. Then our standard deviation is 2 and our mean is 8. So that's going to give us a number of 5.93. So we can actually say x is equal to 5.93 for probability of x less than x. That should be little x, by the way, which equals to 0.15. So I guess we want to give this, what is the longest shower time that Suzanne considered acceptable? 5.93 minutes just sounds a bit weird. So we probably could say showers under 6 minutes are acceptable. Wow, that's interesting. Sorry, I mean, like, I just had a look at the answer schedule. Inverse. Okay, I'm going to have a look at this just to try and figure this out. Now, we have given the answer of 5.93, which is correct answer only. Well, but inverse normal used to find value with working and or diagram. Or diagram. So I guess you kind of have to show diagram. But look, what I will do is I will actually show you guys how to do to get that Z value as well, right? Now, to get the Z value, what you could do is in your calculator, I would draw the diagram, definitely. I'd draw the diagram, and then what I would do is I would actually go into standard deviation of 1 and mean of 0. And when I do this, I actually get negative 1.036. So what you could do is from here, you could actually draw the same graph again, color this up, and then put the mean is equal to 0, standard deviation is equal to 1, which means this value here, Z, is equal to negative 1.036. I would just put that in there just to kind of show the examiner that you know what you're actually doing, because yeah, like if you are asked to show that Z value, it's just to kind of be safe, find that Z value with the second diagram, and then you could just show the 5.93 after that. So I think this here would be a merit. If it's the correct answer only, you're going to get an achieved, which is if you just write 5.93 is going to be achieved, or if you write just the Z value of negative 1.036, you're also going to be looking at an achieved. All right, moving on to the next question. Okay, so with this question, again, for normal distribution, guys, always draw the diagram. So I'm going to draw the diagram here. Thank you. So the diagram here is going to look something like this. So about 85% of the business use less than 2,000 liters. So we know that 2,000 is going to be somewhere here. And if it's 85%, basically this entire part here is worth 85%. And I'm going to put this in a separate part in green, because if the yellow is 85%, so the yellow is equal to 85%, then the green is equal to 35%. So, and I think that's actually needed, because then that would help you, but I guess it doesn't matter because you're using a calculator, so you can figure out what the Z value is anyway. Now we don't know what the mean is, because that's what we're looking for. We know that standard deviation is equal to 450. So I guess the first thing we need to figure out is what the Z value is. So here we've got probability of X less than 2,000 is equal to 0.85. And then when it's normalized, we know that probability of big Z less than little z is equal to 0.85. So I'm going to go into the calculator and get my Z value for 0.85. Now I'm going to go with the left, which is going to be 0.85 and 1 and 0. And when I do this, I'm going to get little z is equal to 1.036. Now if z equals 1.036, you know that z is equal to x minus mu over standard deviation. So this is the formula that we're going to need, and I think this is given in your formula sheet. Level 2 formula sheet. I can't remember. I thought it was. Yes, it is. So if you guys have a look here, it is this formula is given in your formula sheet, so you should be able to use this formula. And we've got 1.036 is equal to 2,000 minus the mean divided by standard deviation, which is 450. Now some people might find this a bit challenging to do, to rearrange this. You can actually use the graphics calculator to solve it, but kind of do this really quickly, folks. So we're going to multiply the 450 first. So we're going to get 1.036 times 450 equals 2,000 minus the mean. I'm going to swap the mean and this big ugly number across. So mean, when it comes to the left hand side, it's going to become equals, not equals, it's going to become positive. And then if I take this to the right hand side, it's going to become minus. So I've got minus 450 times 1.036. So the mean is equal to, I'm going to work it out in the calculator. So 2,000 take away 450 times 1.036, and that's going to give me 1,533 point. I've got 8.8. Don't know why the answer schedule has a slightly different answer. Okay, so now this question also seems like one of these weird double questions here, where it follows on from the first part of the question. So if we go to the answer schedule, so finding Z 1.036, that's going to give you an achieved. Incorrect, mean found with valid working and diagram. That's a T1. Okay, wow, that's an excellence. That's a nice excellence there. So T1 is mean found with valid working. T2 is discussion. Okay, so we'll do the discussion next. Is my washing done? All right, so T1 is we're going to get for this question with the So I'm going to put that as E1 for just the mean found, and I've got diagram as well. Mean found with valid thing. Achieved is 1.036. Merit is incorrect mean found or valid discussion. Okay, so we've got a second part to this as well. Cool, so let's go to the second part of the question. The second part of the question states, a small number of businesses, 1.5%, use more than 15,000. What issues does this raise for part 1 and why? Now with this second part of the question, like if you were to just kind of think about this, right? So we've actually got the mean. The mean of this is 1,533. I'm just going to do it roughly, right? 1,533. Standard deviation is equal to 450. Now, generally speaking, they say that, like, you know, within 3 standard deviations, you're covering 99% of the data from the middle, right? Something like that. I could be completely wrong. I thought it was 65, 95, 99. I could be wrong. But anyway, look, the idea being is that within 3 standard deviations, you're covering most of the data. So if I have a look at this, if I go 1,533 and I multiply it with 3 times, sorry, not multiply, I add 3 times 450. That's giving me about 2,833. Now, that's basically saying at 2,883, you're actually covering 49.5% of the data here from here. So this part is all going to be worth 49.5%. Now, let's say hypothetically we actually work out what the probability of X greater than 15,000 is going to be under this model. If we were to do this, so we're going to go into menu and we're going to go into graphs, no, not graphs, distribution, normal, NCD. My lower is going to be 15,000 and my upper is going to be something ridiculous, like huge. 1533 is this, no, standard deviation was 450, mean was 1533. Now, if I actually calculate this, as you guys can see, the probability is almost, it's coming as 0, right? That's because if you look at it, under this model, we're going to get Z is equal to 29.9. That means this is like, yeah, it doesn't actually work out under this model. So for this claim to work, so we're going to say for this claim to be valid, either the mean has to be much bigger, either mean or standard deviation must be higher. Or else we can say that it's clearly it's not normal distribution. Now I kind of done a couple of diagrams here, and you know, I've talked about the Z value being 29.9. So just the way you guys need to write it is just connect those things. So you would actually say, like, look, under the original model, this was not possible because you know, within 3 standard deviations, you're covering like 2883, and then if you do find out what the Z value is under this model, which is 29.9. Now, if you remember, Z values only go anything above 5, actually not even 5, I think. If you look at the table, anything about 3.9, you pretty much covering majority of it. So that's like, it's almost like 0.5 at 3.9. Now this one has a Z value of 29. It's just, it just doesn't make sense that it's going to have a probability of 1.5. So for this claim to be valid, that's why we say the mean or standard deviation must actually be higher. Cool, so that's question 1. Is it? Yes, it is. That's question 1. Okay, so question 2 here. What's the probability the randomly chosen river is urban river? So it's basically all of this, and is unsafe for swimming. So we're actually looking at this one here. So this is going to be a probability of urban and unsafe. is going to be 57 out of 810. And writing that as a decimal, what are we going to get? 0.0704, and this question is an achieved. Next part of the question. Okay, part 2 of the question is asking, is a river native vegetation more likely to be safe for swimming and then a river an exotic forest area? So we've got native vegetation and safe for swimming. So this is going to be, just going to try and kind of work this through. So probability of safe, given that it's native, safe given that it's native is 146 out of 194. Then probability of safe given that it's exotic, given that it's exotic, so that's going to be 15 out of 26. So those are the two probabilities there. Now what does it say? We've got to write a statement about this because we've got the two probabilities. So first probability is 146 out of 194. That's going to give me 0.7526. Safe and exotic is 15 over 26, which is 0.5769. Okay, so now that I got these two probabilities, what I can do is write a quick little statement. So looking at the probabilities, we can say that P probability of safe given that it's native is more likely to be acceptable and safe. And safe as it has a higher probability. Now you could also talk about probability, you could also talk about the relative risk. Now the relative risk in this case is you got 0.7526 divided by 0.5769. Can I do this straight away? 146 divided by 194 divided by, yeah, what am I doing? Let's go 0.7526 divided by 0.5769. So that's going to give me a relative risk of 1.3045 as 1.3045 times as likely. So that's another way you could actually talk about it. Now the answer schedule does say relative risk is not needed. You could just talk about it with the probabilities. So correct one of these probabilities, either this one or this one, is going to get you an achieved, and the merit is for the statement itself. All right, so next question. Okay, so for this question, what we do need is we've been given the actual proportion of rivers here, but we need to figure out what's all unsafe for swimming, right? So we need to go back to the original table. So what I'm going to do is I'm going to write down all the four types first. We've got native vegetation, we've got exotic, we've got pasture, and we've got urban. Now native veg is 0.48, exotic is 0.05, pasture is 0.46, urban is 0.01. So I've basically got these probabilities, well, percentages from here. Now I need to multiply each of them with the probability that they're actually unsafe. So if I go back to the table, so for native, 48 out of 194 is not safe. It's unsafe for swimming, right? So then I've got to go back here and I've got to type in, do 48 over 194, whatever that is. Then for exotic, I pretty much repeat the same process. For exotic, I've got 11 out of 26. So this is going to be exotic, is going to be 11 out of 26, whatever that is. Then I've got pasture, which is 424 out of 528. So 424 out of 528. And finally urban, which happens to be 57 out of 62. Okay, so that's 57 out of that is unsafe, given 62 of them are from urban. So I'm going to put that as my last one. So now I've got to work out all of these probabilities. So first I'm going to do 0.48 multiplied by 48 divided by 194. That's going to give me 0.1188. Then I've got 0.05 times 11 out of 26. That's going to give me 0.0212. Then I've got 0.46 times 424 divided by 528. That's giving me 0.3694. And then finally 0.01 multiplied by 57 out of 62, which is going to give me 0.00919. Now I've got these four probabilities. So for probability that it's actually unsafe, I've got to add up all of these four probabilities. So I've got 0.1188 plus 0.0212 plus 0.3694 plus 0.00919. So that's going to give me 0.5186. Now it does say, the question does say percentage, so I probably would write it as 51.86 percentage unsafe. And looking at the answers here, because it looks like it's a follow-up question, one of those questions that has a follow-up. So for achieved in this question, any one of these four probabilities, you could get an achieved. There's one probability of river being unsafe. Oh wow, okay, no, sorry, I got that wrong. Achieved is actually getting any one of these probabilities correct. For achieved, is that right? Yes. And then for merit, getting one of either one of these things. So only one out of four. So it's not getting all four correct. So if you just get one of those questions in that achieved column, you get achieved. If you get one of those probabilities correct in the merit column, you get one merit. So you don't actually need all four. Okay, so now the follow-up for this question is that looking at how confident do you feel that this probability would be correct for all New Zealand rivers. Now, look, there's always like two answers in this. I guess the first one that you could talk about is you could be confident. So if you say that you're confident, you can actually talk about how the sample size is actually 810, which is quite large, and the data has been collected by what is it, LAWA, is it? Who is LAWA? Land, Air, Water, Aotearoa. So you kind of would expect that because of that, because they're collecting it, that your confidence level, you could actually support that with how confident you are with this. So that's when you say that you are confident, right? Because you've got a large sample and it's actually collected by, what is it? Lava. Collected by lava, yeah. Now, that's one thing. If you say that you're not confident, now for not confident, what you could say is things would have changed in the last 2 years. So, because if you look at it, this data is for, was it 2020? Where did it actually say? Somebody's getting angry. Yeah, so this is 2020 data right there. So as you can see, it is from 2020, and you are actually doing this paper in 2022. So you could actually say, you know, things might have changed. Things might have changed over the last couple of years. Over 2 years since survey was done. So yeah, I don't think you can actually kind of say that, oh, this, using that we would be saying that these results are actually accurate. The other thing that you could also mention is you could actually talk about the representation of sample of rivers, right? Now, if you look at in the original, sorry, if we look at it here it says that it's actually 48% of the rivers are native. So you got 48% of native vegetation. I don't know why I keep, but then if we go right to the top, and if you look at this part here, so native vegetation is 194 out of 810. So if we look at that probability, so we can say that 194 out of 810, that actually gives us a proportion of way less. Like, it only gives us 24% compared to the actual data, which actually says it's 48%, right? So therefore it doesn't, those two proportions don't actually match up. And so because they don't match up, you can say that you're not confident of this probability as well. So as you can see, there's like 3 different ways in which you can answer this particular question. So as long as you when you answer it, just make sure you kind of justify it with some numerical reasoning, and then you should be good to go. So this question now, if you were to do all, you've got to get the 51.86 and one of these statements correct to get an excellence grade. Okay, so next one here. Okay, so for this question here, what we have got is, well, monitor type is safe for swimming. So safe, first off, safe for swimming, we've got 170 that's actually safe. So probability that river is safe is, we've got 170, and of course we've got to look at the total number of rivers, which is equal to 278, and so the probability of that is 0.6115. Grades wise, we are looking at an achieved for this question, and then we move on to the next one. Okay, so the first thing we've got to figure out is what's the probability that it's unsafe in North Island, and what's the probability that it's unsafe in South Island. So if we go to the table, North Island, we've got unsafe is 74 out of 179. That's the total. South Island is 34 out of 99. So we've got probability of unsafe in North Island and probability of unsafe in South Island. So going back to that table, so as you guys can see, unsafe in North Island, given, so the number of rivers in North Island is 179 and unsafe is 74. So that's unsafe, that's my 74, and 179 is the total number of rivers in North Island. Total number of rivers in South Island is 99. So that's what that is. And then we've got 34 of them is going to be unsafe. So then the 34 is going to pop up here. So once we have those two probabilities, we're going to have to try and work this out. So we got 74 out of 179 is 0.4134. and then we've got 34 out of 99 is 0.3434. So those are my two probabilities that's to start with, and now I need to actually found the relative risk. So I'm going to have a look at Joe's one first. He says it's only 20% more likely for North Island rivers to be unsafe for swimming compared to South Island. So what I'm going to do is, this is for Joe. So for Joe's claim, I'm going to find the relative risk. So relative risk for North Island compared to South Island is going to be 0.4134 divided by 0.3434. So when I do this, not typing it in the calculator, 0.4134 divided by 0.3434, this is going to give me 1.204. And because it's 1.204, I can see that it's actually 20% more likely. So I can kind of write that as a statement. 1.204 is 20%, well, roughly 20% more likely for North Island to have unsafe river than SI, and so we can say that Joe's claim or Joe's reasoning is correct. And now we need to actually look for Mia's one. Now I guess with Mia's one, what she's probably doing is she's actually looking at the number itself. So if you look at for Mia's claim, you can say that 74 divided by 34 is going to give you roughly that 2 point something, because if I do 74 divided by 34, I actually get 2.17. So she's actually looking at the number of unsafe rivers and making this claim, but the problem is she needs to be looking at proportions. So we kind of say that I don't know, she's looking at numbers rather than proportions, and she needs to look at proportions to actually make that claim and not the numbers itself. So yeah, so I'll just write that up a little bit more and decide if it's looking, yeah, so you can actually say therefore it's not valid. Mia's claim is not valid. So grades wise, one correct conditional probability is going to get you an achieved, so either this or this. Merit is relative risk found, which is that 1.204. T1, interpreting the relative risk in context, explaining. Okay, so this is one of those E7, E8 questions, right? Like there's two parts to it. So if you do just Joe's reasoning, you could get an E7, and if you do Mia's claim and Joe's claim, then you could be looking at an E8. Cool guys, that's it for this question. We go to question 3 next. Alright guys, so for this question here, what I'm going to do is I'm going to work out the probability tree, just the basics of it, like, well, maybe not. Okay, so we've got 80% usually try to save water. That's already done. 18%, 2%, 87% were concerned. Okay, so this is going to be 0.87. This is going to be 0.13 that are not concerned. Half usually save water only. Okay, so usually that's a half, which is 0.5. 0.25 is for only restrictions. and then never is another 0.25. Now once I do the table, it just becomes a little bit more easier, because if I look at the first, what's the probability that a respondent about water churn and usually saves? So chosen random is concerned, so concerned is 0.87, and usually saves water. So I'm looking at basically this branch here, which is going to be, I'm just going to write it down, probability of concerned and saves water. Well, it should be usually saves water, is going to be 0.87 multiplied by 0.8. So putting that 0.87 times 0.8, that's going to give us 0.696. And basically that is worth an achieved grade. Now the second part of the question, it says out of the 2,500 survey respondents, how many said they only save water when restrictions are in place? So only save water when restrictions are in place. So that's basically this branch here and this branch here. So we've got to actually try and work out those two branches first. So we've got probability of save water only when there's restrictions. God, my spelling is terrible today. Save water with restrictions is going to be 0.87 times 0.18 plus 0.13 times 0.25. So working that out first, where's my calculator? So 0.87 times 0.18 plus 0.13 times 0.25, that's going to give me 0.1891. And because I've got 2,500 people, I'm going to go 0.1891 times 2,500. That's going to give me 472.75. Yeah, so basically expected, how many said, so expected number here is 473. They also accept 472 respondents. So for a grade of merit, correct probability is going to get you an achieved, and the merit has to be a whole number. So it could be 473 or 472, but you cannot leave it as 472.75 because that would be incorrect, because you want to have whole numbers here as your final answer. Okay, so the next question here, I've got a probability tree. Okay, so we're going to start drawing up the probability tree here. So first off, we've got climate change, which is going to be 0.7. 0.3 is not worried about climate change at all. Then of those that were worried about climate change, 85% were concerned about water shortage. So water shortage concern is 0.85. 0.15 is not concerned about water shortage. And then 55% of those that who are not concerned about climate change were concerned about water shortage. So this is going to be 0.55 and then 0.45 where they are not concerned about water shortage. So down the probability tree, and then we're going to try and work out is concerned about water shortage. So I'm only looking at water shortage, which is this branch plus this branch here. So probability of water shortage is equal to 0.7 times 0.85 plus 0.3 times 0.55. So going back to the calculator, 0.7 times 0.85 plus 0.3 times 0.55, and I should get a probability of 0.76. Grades is worth and achieved. Now they do say that the evidence of probability tree is not necessary, so you can actually get this without the tree. That's going to give you an achieved there for this question. Now part 2 of this question it looks like we're going to need that probability tree, so I'm just going to copy it. Okay, so for part 2 of this question, what we've got is find the probability that a student is not concerned about climate change and is not concerned about water shortages and does not try to save water. Okay, that's a lot there that's happening in this question. So what we've got here is the probability that a student saved water was 2 times greater if they were concerned about water shortages. Now there's 2 parts where there's concern about water shortages. One is here and here, where they save water, so that's 2x. Then we've got save water here and doesn't save water. We've got 2x as the probability. Now that also says the probability that a student saved water was the same when they were concerned about climate change or not. So with the second bullet point, what we've got here is whether they're concerned about climate change or not. So that is where this one is going to pop up with, where they do save water, is when they saved water was the same. So if it's the same, that they were concerned about climate change or not. So whatever that probability is, that's going to just be x. And then overall probability that a student in this survey saved water was 0.5632. So basically this probability of 0.5632 is this branch plus this branch plus this branch, and then finally this branch here. So you should have actually got 4 branches there, and they should actually add up to 0.5632. So if we're going to work it out, we're going to get 0.7 times 0.85 times 2x. And then here we've got 0.7 times 0.15 times x. Here we've got 0.3 times 0.55 times 2x. 0.3 times 0.45 times x. So I'm going to work out all of these 4 branches first, and then when I add them up, I should get them all equal to 0.5632. So I've got to figure out what x is first before I can actually work out the rest of this question, right? So points, let's go to the calculator and start working through this. So we've got 0.7 times 0.85, which is 0.595. times 2, of course, which is going to give us 1.19x. Then we got 0.7 times 0.15, which is 0.105x. 0.3 times 0.55, which is times it by 2, 0.33x, and then 0.3 times 0.45, which is 0.135x. So now I'm going to add up all of this. So 1.19 plus 0.105 plus 0.33 plus 135. This is going to give me 1. So the sum of this is equal to 1.76x, which equals to 0.5632. So basically those 4 probabilities add up to 0.5632. So then I can actually figure out what x is equal to, which is 5632 divided by 1.76. So x is equal to 0.32. Now if you look at the actual question itself, the question itself is asking for not concerned about climate change, not concerned about climate change, which is the red, not concerned about water shortage, which is here, and then does not try to save water, which is this part here. Now because I figured out that x is equal to 0.32, so this is going to be 0.32, and then if I do 1 minus 0.32, I get 0.68, which is this. So then I can say probability of climate change, well, probability of nothing, no concerned about everything, and doesn't save water, is going to be probability of nothing. No, not, maybe I'm just going to write it, right? Not worried, not concerned about climate change, not concerned about water shortages. You know what? I'm just going to go probability of nothing. They don't worry about anything, right? So it's 0.3 times 0.45 times 0.68. So when I do that, I'm going to get 0.3 times 0.45 times 0.68. That gives me a probability of 0.0918. Sorry, I was just being lazy about writing that probability of not worrying about anything. All right, so grades wise, incorrect x values found, blah blah blah, x and one pair of branches considered. So you could get a merit if you just calculate one of these branches and then work out what x is and work it out. So you kind of make a mistake. Correct x value found with valid working is E7, so that is E7, that 0.32. Correct probability of 0.0918 is worth an E8. All right, let's go to the next question. All right, guys, so for this question, we've got a whole lot of things that we need to compare with from the previous questions, right? So the first part that we're going to be looking at is probability of saved water in secondary school from the secondary school survey. Now this one here was, if I remember correctly, that's that 0.5632 there, probability in the survey saved water. So this is from part 2, right? So that's 0.5632. And if we look at probability of save water in the general survey, so that's at right at the beginning. So this was where the large online survey was carried out. So if you look at the usually saved water, which I think, did we find this? No, we didn't. So the usually saved water then would be these branches here. I'm going to try and do this. So we've got the usually saved water there, or the usually saved water there. So I'm looking at those two red lines, which is 0.87 times 0.80 plus 0.13 times 0.5. So when I work this probability out, so I've got 0.87 times 0.8 plus 0.13 times 0.5. This is going to give me probability of 0.761. So I'm going to use that probability right at the end there, 0.761. Now, you know that working that I did on the top, I'll probably put the working down here. So I've got these two probabilities here. Next is I'm going to work out the relative risk. Now it says 25% less likely to save in their homes compared to the general population. So I've got 0.5632 divided by 0.761. So when I do that, oops, what is it? Whoa, what was I doing here? Sorry, it's kind of working on the answer schedule and this, but there we go. That's how we get that 0.761. Now I've got 0.5632 divided by 0.761. So this is going to give me 0.74. So we can kind of say that probability of students saving water is 0.74 times as likely, which is 26% less likely, right? Just gonna write that down. Oh God, talk about spelling mistakes today. Less likely than probability of general NZ population saving water. So this is roughly 25% less likely, so the claim could be valid, right? This is about 25% less likely, so claim could be valid. Now there is another alternate solution as well. Now you might actually say that when we think about saving water, you know, the red line that I actually marked was only usually save water, but your other alternate version that you could have is you might actually say, well, this person here saves water, this one also saves water, and then this one saves water, this one also saves water. So you might actually have the red line plus the orange one here plus this orange one here. So you've already got that 0.761, but you might actually add, so you might actually have 0.87 times 0.80 plus 0.87 times 0.18, that's the new orange one, plus 0.13 times 0.5 plus 0.13 times 0.25. So that's kind of adding those orange lines now. So if that's the case, I'm going to get 0.761, which is that original one, plus 0.87 times 0.18 plus 0.13 times 0.25. Now this is actually going to give me 0.9501. Now this is, remember that this is the second situation here for 0.9501. So in the original equation we were just looking at saving water purely, but we could have a second situation where we're looking at probability of save water that's even when restrictions are on. So you're actually looking at that whole with including the restrictions as well. So if that's the case, then your new probability is going to be 0.9501. Now, like I said, this is a other interpretation. You might have a second interpretation. So in this case, we're going to do a relative risk again, and the 5632 is still the same. So 0.5632 is still save water from the school survey, but from the general survey we went to 0.9501. Now in this case, this is going to be something 0.5, I'm guessing 0.5632 divided by 0.9501, that's 5928. And so we are going to kind of write the same statement that we just wrote here. So we're going to have, I'm going to kind of cheat here just because I'm too lazy to actually write this whole thing again. Paste. So instead of 0.74, it's actually going to be 0.5928. Now this is actually quite much, right? Like it's not 26%, it's actually close to 40% roughly. And this is about 40% less likely. So claim is not valid. Sorry, that's just me being incredibly lazy about writing those statements. So there's two situations that could potentially happen. Now, the last thing is, like, it does ask about discuss the validity of the claim and use relevant calculations, and I've done all of that. So having a look at this, a couple of things to consider. If you look at that second, the teacher that actually found, so where was this? This was a bit important here. So this second survey, it was actually from 2 local high schools, while the first survey, it asked 25,000 New Zealanders, and that was actually done online. So those are a couple of things to consider, right? So the first point being is that, you know, the second survey, Second survey only did 2 schools, was surveying only 2 schools and surveying only 2 schools. And so representing all of New Zealand is probably not so wouldn't represent all of New Zealand. So would represent all of New Zealand. Just because, I mean, like, you know, depending on where the schools is, like, you know, you're going to get like completely different answers. The second bullet point is you've got 2 different kind of ideologies, right? Like when you look at it, there's differences. There's differences in how people save water. Like for example, like how do we, like when we talk about saving water, are we actually talking about people that save water during restrictions? Like that kind of makes the comparison quite difficult. So example, when restrictions are on, so I would just write that up a little bit more, because that makes like you guys can see, right? Like when we had the 2 different relative risks, one of them was actually much more higher because we kind of included those people that were saving water when the restrictions were on. So therefore it makes making comparisons difficult. That's going to be number 2. And the last one is online surveys. I mean, online surveys may be biased. And that's just another kind of something to actually consider putting up there as well. So grades wise, what do we have? This is a lot of things that are happening here. So let's just see. Now 0.761 found could get you an achieved, or 0.9501 gets you an achieved. Probabilities compared using relative risk. So relative risk here could get you, either one of those 2 things could get you a merit. And conclusion made regarding with clear discussion. Is this an E7 or an E8? No, this looks like just a E8 question. And then excellence is actually talking about conclusions made and with clear discussion of validity of claim. So you've got to do the conclusion, and you've got to do one of like with a clear discussion of the validity of claim. So yeah, just putting those. Now you might be asking, is it all 3? I would say it does say clear discussion of validity of claim. So, you know, just trying to write like a couple of points would be safe for you guys. All right, folks, that's the exam paper for you. Now, as I said, this is the first time I'm doing this paper, so any feedback is appreciated. Any comments, just leave them in the comment section. And I'm sure there's a couple of things that I probably made mistakes with. I will take responsibility. But if you do find that there are quicker ways to do any of these things, please make sure you put them in the comment section. Cool. Good luck for your exams. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.